hammered seashells into their jaws to replace missing teeth. Those seashells were likely the first dental implants. Today, titanium tooth implants fill the gaps nicely, and usually the patient's jawbone will actually bond to them. In the middle of the 20th century, it was discovered that titanium is a metal that bonds with bone. It revolutionized restorative dentistry, making enduring tooth implants possible. To make these implants, they start with a solid titanium rod. This 4-meter rod will be used to make more than 200 implants. The technician inserts the rod in a long tubular device, which keeps it straight as it feeds it to a lathe system. The titanium rod spins as computerized tools slim it down and cut threads into it. These threads will help anchor the implants in the patient's jaw. The lathe pushes the rod out and then pulls it back in repeatedly to facilitate the shaping process. A tool now grips the implant while another cuts it to length. Then a computerized drill hollows out the implant and carves threads inside for attaching the ceramic tooth. In minutes, a solid metal cylinder becomes a hollowed and threaded implant. A robot now retrieves the implant from the clutches of another one. It transfers it to a cleaning station and then over to what's known as a vision measuring system. Here, a camera takes pictures of the implant from all angles and sends the images to a computer for analysis. The computer confirms the dimensions are exactly right. Then the robot collects the implant and places it into a slot in a tray. Once filled with implants, a technician screws a mesh lid on the tray and slides it into a metal basket. This basket positions them for cleaning in a special washing machine known as a vapor degreaser. Inside, solvent vapors envelop the parts to clean off residual lubricant oils used during the cutting process. A robot transfers an implant to a holding device. The device secures the implant for the next robot to press a plastic collar onto it. This collar is temporary. It will serve as a mask to protect the outside of the implant as the top undergoes a process of colorization. A robot places the implant upside down in a mild acid. They apply an electrical charge. Different colors will appear at different voltages to color code the part and indicate the diameter. The process is called anodizing. A robot now pulls off the masking collar. It transfers the implants to another tray and screws them onto it. This keeps them from falling off as machinery turns the tray upside down to immerse the implants in acid and anodize the exterior. This time, the anodizing serves another purpose. It changes the surface to make it more porous. This will improve the bonding of the patient's jawbone to the implant. The implant sparkles in the solution as it undergoes a transformation. Here's the new porous surface magnified by a microscope. A robot transfers the dental implants to another tray. They're now ready for a final cleaning. A technician puts a lid on the tray and lowers it into a tank full of hot, purified water. A generator sends high-frequency sound waves into the water, creating bubbles and waves that gently scrub the implants. After sterilization, these titanium dental implants are ready to take root in human jaws. The clinician screws the implant into the patient's jawbone and then secures a made-to-match ceramic tooth to it. Over time, bone will fuse to this artificial tooth, providing a long-lasting tooth replacement and giving the patient a reason to smile.